Okay, so we would like to identify the molarity given the mass of solute and the total volume of solution. Do you think you can do this, Fred?
I think I can do it.
All right. Let's let the folks at home have a chance at it. Push pause. See if you can figure this out. Okay. Did you do it, Fred?
I know how to do it.
What goes to the right of our equal sign?
We want molarity.
That's right. And molarity means what?
That's moles per liter.
That's right. Molarity is not just moles, but moles of solute per liter of solution. And what's the solute in this case?
In this case is sodium chloride.
That's right. Solute in this case is our sodium chloride. Good. All right. So that's moles of sodium chloride per liter of solution. So what do you want to start with?
10.0 grams of sodium chloride.
10.0 grams of sodium chloride.
And then convert that to moles.
Okay, we know we want to go to moles of sodium chloride because those are our units that we want to have on top. So we go grams of sodium chloride to moles of sodium chloride. What is the molar mass?
58.44.
Okay, so 58.44 grams for every mole. All right, so now we're in moles of sodium chloride, and now we just need what?
Liters of solution down below, so that's 75 milliliters.
Okay, so do I have to have something up here?
No, you just want it down below.
That's right, I want my liters of solution down below. 75 milliliters. Those aren't liters, are they?
No, but you can convert them.
That's right, I can go from milliliters to liters. There are 1,000 milliliters for every 1 liter, right?
Yeah, that's right.
Okay, very good. So 10 divided by 58.44 divided by 75 times 1,000, right? Whoops, that was times 100. So 2.3.
2.28.
Yeah, 2.28, sorry. 2.28, 3 significant digits. That is our molar concentration of sodium chloride in this solution. Okay, great. So now, dilution. Dilution. You guys are familiar with dilutions.
Well, I've heard the word before.
Yeah, but you've also actually done dilutions in your life, right? Fred, remember that time we went to that party at, it was here on campus somewhere. It was down, I can't remember what building it was in.
Oh, I think so. And they had that big spill.
Yeah, that's right. They spilled a bunch of red punch, right?
Yeah, it was on the tablecloth.
Yeah, they spilled a bunch of red punch on the tablecloth and it made it all red. Remember that?
Yeah, I only remember that because the punch was so sweet that day. It was like somebody wasn't even tasting it.
Yeah, that's right. We were given some punch, and the punch, the bowl of punch, right, was so red, so sweet, right?
Yeah.
And that cup of punch, right, needed to be diluted, didn't it?
Yeah, it needed to be diluted.
Okay, so dilution, how did we dilute that punch?
Well, I just added some water.
That's right, you can add water to punch to dilute it. Okay, so if we add water to our punch, we're diluting it. So here's some example of a compound or a chemical solution. We could think of this as punch, and we're diluting it. And you notice how it becomes less concentrated. The solution's color becomes lighter, right? So the red punch here, when we diluted it, it became lighter. Now let's say that the punch's concentration was, let's give it a number. Can you give me a number?
7?
All right, let's say it was 7 molar. And let's say we wanted to dilute it down to half as concentrated, Fred. How much water would you have to add?
Half as concentrated?
Yeah.
If you want half as concentrated, you have to add the same amount of water as you have punch.
Very good. I think that's intuitive if we think about that long enough. So if I have a cup, I'm going to need a slightly larger cup, right? But if I have a cup here, and I add in my red punch to here, and then I add water up to there, the solution's concentration will now be half as concentrated. So if this was 7 molar, what will this concentration be?
That will be 3.5 molar.
3.5 molar. Good. So 7 molar goes to 3.5 molar if I dilute it in half. Can you make up a volume here for me, Fred? What was the volume of this solution?
That's 1 cup.
Well, let's do it in liters. Can you give me a liter?
Okay, so that's 1 liter.
All right, that's 1 liter. So what's the resulting volume of this solution going to be if we added another liter of water?
Well, it's 2 liters.
That's right. That's going to be 2 liters. That volume is going to be 2 liters. Okay. So here we had our concentrated solution. We have our concentrated solution's concentration. We have our concentration solution's volume. And here we have our diluted solution. We have our diluted solution's, what's that?
It's the volume.
And what's this?
The diluted solution's concentration.
Very good. And there's this relationship that exists between the concentrated solution's volume and concentration and the diluted solution's concentration, volume and concentration. Do you follow that?
Okay, I can see it. Yeah, it's like 2 to 1.
Right. And if we call this the volume initial, V1, and this is the concentration initial, and this could be like C2 or CF sometimes. You can see different ways of expressing it. Oh, sorry, this is the CF, and this is the volume final. We see that a relationship exists. Okay? Now, for beginning students, oftentimes they're told memorize this equation, and that's good. But when it comes down to it, the people who miss these problems are the ones who have trouble memorizing that equation or forget it momentarily, right? But if you remember the time you were at a party and you had a solution, a drink, punch that was too sweet, and you had to dilute it, right? Then you can regurgitate, create numbers, dilute it down half as much, and then regurgitate the equation for yourself. Let's see. It looks like C1 divided by CF, 7 divided by 3.5 would be the same as 2 divided by 1, right? Can you see that? So C1 over CF, C initial divided by C final equals what?
VF divided by V1.
VF divided by V1, or V initial, that's right.
But that's not what the slide says.
Oh no, the slide doesn't say that, does it? But it is actually the same equation. If I just rearrange it, C1 and bring the V1 over there, and set that equal to CF and the VF. See that?
Okay, I see that.
And our intuition could have brought us there first. We could have said, oh, look, I see that this times that is equal to this times that, right? You might have seen that. Either way, both of these relationships will help you answer what we call dilution problems. Okay? So to regurgitate the dilution equation, you need to remember the time that you diluted a drink that was too concentrated and identify volumes and solutions or concentrations and then find the relationship that works. Okay? So let's use this, apply this to this scenario. What volume of 12.1 molar HCl are needed to create 250 milliliter of 3.2 molar HCl? So we see that this is a dilution problem because they're having a concentrated thing and they're making a dilution of it and they're trying to find out what volume is needed. So then I remember my C1 V1 equals, and I'm just going to do C2 V2. Sometimes you see it as final, sometimes you see it as 2. It depends on the professor, and I'm flexible. So what's my initial concentration here, Fred?
Is that the concentration of the high one, 12.1?
That's right. I start off with 12.1. What volume of it did I start off with?
Well, they don't tell you.
That's right. That's what we're after. And what's the final volume of the material or the solution that I want to make?
Was that the 250?
Yeah, that's the 250.
Does it have to be in liters?
Well, whatever units I have here, I just know that those are going to be the units that I end up here. So this is molarity. I just want to make sure I have molarity over here. This is milliliters over here. I know I'm going to end up with milliliters in my answer. If I had converted this to liters, then I would end up with liters in my answer.
But that's not the concentration, that's the volume.
Oh yeah, that's right. This is the V2. So C2 is the 3.2, and then the final volume, which is in milliliters, is the 250. Okay, so 12.1 times X equals 3.2 times 250. So I get my calculator. These are equal to each other, so these two, 3.2 times 250, divided by the 12.1, and that tells me X equals 66.1. And what are the units again?
You said milliliters.
That's right, it's going to be the same units as the 250 then. So that's the volume of HCl, the 12.1 molar HCl needed to create that solution that's described there. All right, very good. So 25 milliliters of 6 molar HCl is diluted to 500 milliliters with water. What is the molarity of the resulting solution? Now notice that it doesn't say we added 500 mils of water, does it?
Oh no.
Because if it says you add water, then you have to make sure that you realize that your resulting volumes are additive. But in this case, it says we're just diluting to 500 milliliters with water, right? So what's our initial concentration? We have our C1, V1, CF, VF. Oops, VF. What is our initial concentration?
6 molar.
Very good. And our initial volume?
25 mils.
Okay. And what's our final concentration?
That's what the question is asking.
All right. What's the resulting molarity? And then the final volume.
500 mils.
500 milliliters is the final volume. So 6 times 25 divided by 500. And that's going to be 0.3. 0.3. That's what our X will equal to there. And the units are what?
6 was in molar, right?
This was in molar, that's right. So this is going to be in molar. Very good. Okay. All right, here's one for you to practice by yourself, Fred. Go ahead and give it a shot, and then when you're done, we'll go over it, okay? Everybody push pause and try it. All right. How'd it go?
I think I got it.
What's the answer?
I think it's B.
All right, so C1V1 equals C2V2, is that right?
Yeah, okay.
What's the initial concentration?
3.11.
And what's the initial volume?
20.
All right. Milliliters. What's the final concentration?
That's what you're after.
X. And the final volume?
That's 15.
15?
Yeah, 15.
Well, 20 milliliters of this stuff are added to 15 milliliters of water. It doesn't say that 15 is our final volume.
Oh no. Okay, so you add them together?
Yeah, because here it didn't say the final volume was 45, or it went up to a volume of, sorry, final volume was 15, or the resulting solution's volume was 15, right? It says that you added 15 milliliters of water. So the result is going to be 35 milliliters times final.
Well, then B's wrong.
That's right, B's wrong. And it doesn't make sense that we started with 3.11 and we went up in concentration when we added water. So that should have been something that kind of led you to realize that that wasn't correct. Okay, so then 3.11 times the 20 divided by the 35.
Okay, that makes sense.
So X equals 1.77 molar. Follow that?
Yeah, I got it.
Okay, good job.